Let us discuss third and part of integration miscellaneous exercise. So already two sessions over. So let us start our new session, third session, and from question number 12 of the exercise. So let us continue now. In question number 12, integral of x cube over root of 1 minus x power 8 and dx. Okay. Then what is the connectivity between x cube and x power 8 we need? Otherwise, integral of this type of question is a little difficult. And 3 and 8, how to connect then x power 3 and x power 8? X power 3 can be derivative of x power 4. Whenever we differentiate x power n, it's a derivative, degree is less by 1. The degree of the derivative of x power n less by 1. So we can connect the x power 3 with the x power 4. We can write the x power 3 as a derivative of x power 4. But derivative x power 4 is not only x power 3, some real number 4 into x power 3. The 4 and coefficient always adjustable. Okay, we should not adjust with any variable. We should not keep any variable outside of the integral, but we can keep constant coefficient outside of the integral. That is why here we should integrate using substitution. We can take a t is x power 4 and t x power 4, then dt will be equal to 4 times x cube dx. Now the numerator x cube dx will be 1 by 4 dt. Now let us start our solution based on the substitution. I equal to, instead of x cube dx, 1 by 4 dt and root of 1 minus t is x power 4. What about x power 8? T square. This is a direct formula. Sine inverse of t with the parameter known as integral constant. Final answer always in terms of the given variable, and t is x power 4 with the integral constant, and you can copy it. This is the answer. Then we'll go to question number 13. And question number 13, integral of the numerator e power x, the denominator 1 plus e power x into 2 plus e power x at dx. So this can be reduced to apply and partial fraction. Let us take t is e power x and differential of t dt, differential of e power x dx. So let us start our solution based on our substitution. I is the numerator e power x dx is a dt, the denominator 1 plus t and 2 plus t. By partial fraction, 1 over 1 plus t into 2 plus t. There are two linear factors in the denominator, so we have to give two simple partial fractions with the linear denominator. A over 1 plus t, one of the partial fractions, and another one b over 2 plus t. and we need to find A and B. If you follow the shortcut method, when t equal to minus 1, because the 0 of 1 plus t minus 1, then we have to put the t equal to minus 1 on the left side, avoiding 0 factor. We'll give no a 1 over, and if t equal to minus 1 means the first factor is 0, so it should be avoided. The second factor not 0, it should be included, and 2 minus 1 1, that is a equal to 1. When and t equal to the 0 of the second factor, that is minus 2, what about b? The numerator 1, denominator 1 minus 2 minus 1, and the second one 0 factor don't include. So b equal to minus 1, and a equal to 1 and b equal to minus 1. A is 1 and b is minus 1. Okay. Now you can integrate. I is a into integral of dt by 1 plus t, and b is minus 1. Integral of reciprocal of a linear function with a derivative 1 and log of L. This is L, actually linear. The differential of L dt. The second 2 plus t. A by b log mod of, and t is e power x. So e power x plus 1 and e power x plus 2 with the integral constant. So this is the final answer of question number 13 from miscellaneous exercise of integral calculus. Is copied. We move to question number 14. Is copied. And question number 14, integral of dx over x square plus 1 and x square plus 4. Actually, the integrand in terms of x square, I is a function of x square, then we can identify the integrand and even function. What is the importance of even function or f of x square? It cannot be integrated in terms of new variable. But the new variable, that is substitution, is a temporary arrangement, and to separate the given integrand as 2 or 3 partial fraction. Once the partial fractions done, then you have to integrate only in terms of x square. We cannot in terms of the newly introduced variable. What is the reason? What is the derivative of x square? The derivative of x square and 2x dx. The x term is missing. There is no x in the numerator. We cannot adjust any variable by multiply divide. Otherwise, we have to keep 1 by x outside. It is a violation of the rule. That is why this is not possible. This is not available. So we cannot integrate in terms of new variable. We should try to adjust and in terms of x square, or substitute x square equal to some u or v and complete your partial fraction and recover the original variable, then integrate. Okay, but this is easy type of question. Why I am saying, and 1 by x square plus 1 into x square plus 4 by difference method, it can be adjusted. The What is the difference between x square plus 4 and x square plus 1? 4 minus 1, 3. We can take 3 as 1 by 3, multiply divide by 3. 3 is nothing but the difference of these two factors. The numerator 3 can be written x square plus 4 minus of x square plus 1. Is it not? The denominator x square plus 1, x square plus 4. Now we can separate as 1 by 3. The first and fraction 1 by x square plus 4. The second one 1 by x square, and x square plus 4, 4 cancel, this is 1, then minus x square plus 4. Okay, so the separation by difference method is done. Now we can go to integration straight away. Integral of 1 by 3, integral of dx by x square plus 1. X square plus 1. The second term again 1 by 3, integral of dx by x square and plus 4. It's a direct formula at 1 by a tan inverse of x by a. That formula should be applied. In the first integral a equal to 1, so no need the separate factor 1 by a. Yes, 1 by a is 1 by 1, and tan inverse of x by a x alone. Minus, here a equal to 2 means 1 by a 1 by 2, 1 by 2 into 1 by 3, 1 by 6. And tan inverse of x by a is 2 with the integral constant. Okay, and copy it. Then we will go to next question. Question number 15. Integral of and cos cube x and e power log of sin x. And log mean to the base e and dx. Remember student, and e power log anything from 5 and to the base e is nothing but 5. The fundamental and formula. This is a composition of exponential function and logarithmic function. Because exponential function and logarithmic functions are inverse to each other, the composition of and the function which are invertible or inverse to each other is always an identity function. So object and the image will be equal. This phi is object, this phi is image. Both should coincide because of the identity nature. Okay, now using this formula, and we can rewrite the given integral as follows. And cos cube x, what about the second factor sin x? And cos cube x and sin x mean we can separate sin x dx. The sin x is a derivative of minus and cos x. Minus and cos x. Okay. So integral of and cos cube x, how to write sin x dx, and derivative of and minus cos x. Or we can take at substitution to t equal to and cos x or minus cos x or cos x, t equal to cos x. What about dt? Minus sin x and dx. So instead of sin x dx, we can take minus dt and t. So at d of minus cos x means the negative part can be taken out, or following this minus integral of and t square dt. Then integral of t square t cube by 3 with the integral constant. The final answer, as we discussed every time, and should be in terms of given variable x, function of x. So I equal to minus 1 by 3 and t is cos x and cos cube x. I think, and there the power should be 2, cos square cos cube 3 mean, then the final answer not t cube by 3, it should be t power 4 by 4 with integral constant, and we need a change in the final answer also, minus 1 by 4 and cos for 4x with the integral constant. Okay, and copy it. We'll move to question number and 16. Question number 16. And 16th question, integral of and e power 3 log x into x power 4 plus 1 whole power minus 1 dx. Okay. So as we discussed the previous question, remember student, e power 3 log x is nothing but x cube. X cube. The 3 becomes the exponent of x. E power log x cube is nothing but x cube, following the previous formula. E power log 5 equal to 5. The same thing. So let us start the solution part. I is and e power 3 log x cube including dx, x cube dx. Then what is the reciprocal form of x power 4 plus 1 whole power minus 1, 1 plus x power 4. If we take t, the entire denominator, 1 plus x power 4, the corresponding differential on the left side dt and right side 4x cube and dx. But we have x cube dx should be 1 by 4 dt. Then what about I? 1 by 4, this is plus 1 by 4 at dt by t. Is a familiar form. What is integral of dt by t? Log mod of t with integral constant. And final answer I is 1 over 4 log, and t is nothing but 1 plus x power 4. And both are positive, so normal bracket enough and plus c. Otherwise, modulus symbol should be given. This is question number 16. You can copy it now. We'll go to next question, 17. And it's question number 17, integral of and f dash of ax plus b into f of ax plus b double dash. F dash of ax plus b and f of ax plus b and double dash at dx. Okay, and f of ax plus b whole dash is a derivative of first function. Derivative of first function mean, remember student, the second term f of ax plus b and double dash would be written a differential of f dash of ax plus b. Am I correct? So differential of f dash of ax plus b, f double dash of ax plus b dx. So now we can undo this using simple and substitution. Let us take and t equal to f dash of ax plus b, and this implies dt will be equal to f double dash of ax plus b into uh, dx. This is the first and derivative of and t dt derivative of f dash f double dash. But if we apply chain rule and a should come here, this is what is given f double dash, the whole thing is included including a. For example, and t equal to f dash of ax plus b means what about dt, usual thing, and by chain rule f double dash, then we have to differentiate ax plus b. Ax plus b is a dx, a dx. Okay, so in because of a, here what will come 1 by a. So derivative of f dash of ax plus b by a equal to f double dash of ax plus b. Correct? Now I equal to integral of, instead of f dash of ax plus b t, f double dash of ax plus b is dt by a. You can take a outside dt. So t dt 1 by a integral of t square by 2 with the integral constant. So final answer I will be equal to 1 by 2a. What is t? F dash of ax plus b whole square with the integral constant, and copy it. This is the answer. Okay, we'll do one more question. Question number 18. Integral of and dx over within the square root sine cube x in the sine of x plus a, and solution. Let us take I and dx in the denominator root of sine cube x. Now what to do? And we can expand the sine of x plus a using compound angle formula, sine x and cos a and plus cos x sine a. And if we take the sine x is a common factor from the second factor, the sine cube x becomes sine power 4x, the remaining without the sine factor, and cos a, cos c, I have taken a, okay, cos a, in the book it is alpha, not a problem, and cos a plus and sin a in the cortex. So this is nothing but and root of sine power 4x sine square 1 by sine square x cosecant square x dx, the denominator root of and cos a plus sin a into and cot x. Dear student, if we take and t is entire denominator within the square root, cos a plus cot x into sin a. What about dt? Derivative of cos a 0. Yeah, this is constant. Sin a coefficient and cot x minus sin a cosecant square x dx. Cosecant square dx, correct? But if you look at the numerator, cosecant square x dx, what is cosecant square x dx? And 1 by sin a and dt, 1 by sin a dt. So I equal to the cosecant square dx minus 1 by sin a and dt in the numerator, denominator root of t. So minus 1 by sin a, integral of dt by root of t by formula 2 root of t with integral constant. So final answer minus 2 by sin a or minus 2 cosecant a into root of the entire thing should be taken, and cos a plus sin a into cot x with the integral constant. So dear student, and let us wind up on today's session with question number 18. Then we'll continue miscellaneous exercise of integral calculus and session number 4 in the next class. Thank you students.